So I'm Pratik Jain and I'm going to cover the basics for X-ray, basics for radiography and all of that. So let's get started. So this is the basics of X-rays. So you have a X-ray generation block, and let's say there's a person whose X-ray you want to scan, and there's a detector. Okay. So there's the X-ray that will be emitted and that will pass through the body. They'll pass through the body and there'll be some interaction with the body which will have some X-ray residual which will hit the detector and we get the image. So that's the very basic of X-ray. But what exactly is X-ray? Anybody? What is X-ray? Yeah? Exactly, yes. So X-rays are highly energetic light rays or electromagnetic rays that we cannot see. So I guess you would have seen this a lot of times. So this is the electromagnetic spectrum, and there is this very small bit over here. Oh, you cannot see my mouse pointer. Okay, so there is this very small bit over here which is visible light. Everything else is something that we cannot see, and these are the different wavelengths of the EM wave, and the X-ray lies over here. So we are going to focus mainly on these rays that are over here, and these are ionizing radiation. I'll come to this in a bit, but yeah, so there is something called as non-ionizing radiation, which is good for health. I mean, that won't cause any radiations in the body. And then there is ionizing radiation, and X-ray is one of that. It is an ionizing radiation. Okay, so we cannot see X-ray. How do we know it exists? Well, can we feel its mass? Well, no. EM waves have no mass. Can I use electricity or magnetism to see it? No. EM waves are unaffected by either electric field or magnetic field. Does it use something to propagate or travel? No. It does not require any medium for propagation as well. So what to do? What is it that they have? What is X-ray? So they are nothing but energy. So in general they have energy. And can we detect that? So yeah, just like our eyes detect light rays, X-rays are, so there is something called as detectors which have scintillators, and this help you convert the X-ray to visible light. Okay, so these detectors have some scintillators, and whenever the X-ray hits the detector, you see the light. That's visible light. How much energy do they have? So that's given by this equation. So the energy in any electromagnetic wave is given by hc by lambda, where h is the Planck's constant, c is the speed of light or speed of the EM wave, and lambda is the wavelength. So an interesting thing over here is energy is directly proportional to speed. That's quite, so anything that is very fast will have more energy, and it is inversely proportional to lambda. So that's the wavelength, and that's like, I mean, the more distance, so it's like, so lambda is this thing, one kind of entire wave, the length of an entire wave that repeats again and again, and the more the lambda, the less the energy. Yeah, that's the other equation where E is equal to h nu. H is the Planck's constant, which is over here, it's just a constant. So this is the frequency wave formula, and that's the lambda wavelength energy formula.